Hello everyone, today we are going to do Learning Target 3, Perimeter and Area of Similar Figures. Remember that if I go too fast, go ahead and pause the video. You do want everything that I write or have on my screen on your notebook paper. Okay, so feel free to pause it if you need to. Alright, so key concept. We're just going to try a couple problems. We're going to write down some ratios. And we're just going to take a look at the ratios and just see what happens. Okay, so this first one, I have two squares. One of them has side lengths of 1, the other one has side lengths of 2. So the first thing we're going to write down is the side ratio. So from this shape to that shape's ratio is 1 to 2, so it's a half. The next thing we're going to write down is the ratio of the P, which is perimeter. Okay, so that means I need to find the perimeter. Well, it's a square, so all the sides are 1, so the perimeter is going to be 4 units. And the perimeter for this one, since all the sides are 2, is going to be 8 units. And again, if I'm writing the ratio from this one to that one, it's going to be 4 over 8, which actually reduces down to 1/2. And then we're going to do the ratio of the area. Okay. So remember, for a square, it's base times height, so I'm doing 1 times 1, which is 1 unit squared. And then over here, I have 2 times 2, which is 4 units squared. And again, I'm going from this shape to that one, so it's 1 over 4. Okay, so we're just going to go through a couple examples. We're going to do this. We're just writing the ratios of the sides, writing the ratio of the perimeter, and writing the ratio of the area. When we're all done, we're just going to take a look at all that data we collected off to the right side, and we're going to see if there's a relationship somewhere. So on the next problem, again, I'm doing the side ratio, so S ratio. Go from one shape to the other is 1 over 3. Then I'm going to do the perimeter ratio. The perimeter over here is going to be 4 units still, but the perimeter here is going to be 12 units. So from 4 to 12, and if I reduce that, that is 1/3. Then I'm going to do the ratio of the area. So the area here is still 1 unit. The area here is 3 times 3, which is 9 units squared. If I go from this shape to that shape, it is 1/9. So the area ratio is 1/9. All right, so we have one more example down here. I have, let's say A and A are the side lengths, and over here I have B and B. Okay. Before I continue, why don't we take a look at these two ratios? Okay, in the first problem, I want you to take a look at between the side and the perimeter. What do you notice? Side and the perimeter, what do we notice? They're both equal. Okay, so the ratio of the sides to the ratio of the perimeter are going to be equal, and that's because I'm using the sides to find the perimeter, right? I'm just adding up all the sides. So their ratio simplifies down to the same number. So we got to keep that in mind. All right, and then from the side to the area, what I want you to notice, so take a look at both examples. From the side to the area ratio, what am I doing? Yeah, if I take 1/2 squared, it's going to give me 1/4. And if I take 1/3 squared, it's going to give me 1/9. Okay, so I'm squaring it. So if I go from the side ratios to the area ratio, I need to square it. And that's because when I find area, I'm squaring the dimensions. So the ratios are getting squared as well. All right, so down here, when I had sides just A and B, this is kind of like the general setup for all the problems that you're going to do, is if I have side ratio, it's just going to be A over B because I'm going from this side to that side. And I already know I don't need to find the perimeter. When I do perimeter ratio, I know it's going to be equal to the side ratio, so it's just A over B. And the reason being is when I find perimeter here, I have 4A. And when I find the perimeter here, I have 4B. Okay? 4A over 4B, well, 4 divided by 4 is 1, so that goes away, and I just have A over B. That's why that works. Okay, when I do the area ratio, I already know that I'm going to square the A over the B and square both. Okay? Because the area here is going to be A squared, and the area here is going to be B squared. So when I write that ratio, I have A squared over B squared. Okay, so this is the general setup for our problems, because I'm going to be giving you problems where I don't give you all the pieces of information, and I want you to find the area, or I want you to find a side length. And all I'm giving you are ratios. So that's why we had to find the relationship between the ratios so that we could find those pieces of information. All right, so on the next page, let's kind of formalize this a bit. In all of our problems, I know that the ratios of the sides A over B. I know that the ratios of the perimeter is going to be over B. And I know the ratio of the areas are going to be A squared over B squared. Whatever the side lengths are, that's how it's going to go. Okay. So obviously the ratio of the sides and the perimeters are equal. But to go from the ratio of the sides to the ratio of the area, I'm going to need to square the fraction. And the square A and B. But sometimes I might give you the area ratio. So we need to know, how do we go from the area ratio and get the side ratio and the perimeter ratio? So if I'm going from the area to the perimeter, or to the side, I have to undo the square. And the thing that undoes the square is the square root. Okay? So you're going to square root the ratio. And we're going to square root the ratio to get the side ratio and the perimeter ratio. Again, if you don't know why we need to know this, I'm going to tell you right now. We're going to do the steps, okay? I'm going to give you a problem where I give you one of these ratios, just one of them, okay? And then I'm going to ask you to give me the area. And you're going to have to take the, the side ratio and somehow provide me the area of the shape. So knowing these relationships are going to help us get us there. So here's the steps to do the problems. Okay, step 1. You're going to make the ratio they give you, okay? It might be the side ratio, it might be the perimeter ratio, it might be the area ratio. Whatever ratio they give you, you're going to make it, okay? Then 2, you're going to identify the type of ratio your variable is in. So if they want me to find the area, then my variable is the area, which means that's the type of ratio I need to find, is the area ratio. Okay, if my variable is a side, they want me to find a side length. Okay, then my variable is going to be the side, which means I need the side ratio. After step 2, step 3, you're going to convert the given ratio to the type of ratio your variable is in, so the one that you're identifying. After you do that, now your ratios are of the same units, and now you can set up a proportion and solve, okay? So for it to be a proportion, you have to have the units be the same, so that's why we have to convert it in step 3, so that the ratio of what I want and the ratio of what's given to me have the same unit. And that's why we need to know the relationships between the ratios so that we can convert it. I know a lot of this doesn't make sense right now, but in a second when we do a problem, it'll start to make a little sense. So make sure you have those steps written down and you have the ratios above written down because they will be your guide to doing these types of problems. Feel free to pause the video if you need to write all that down. All right, we're going to do this problem together, guys. All right, it wants us to find the area of the small figure. And the problem with that is I can't find the area of this small figure because I have a base, but I don't have a height. And that's why we need to know those relationships between the ratios, because I'm going to give you problems where I don't give you enough information. Okay, but I am going to give you a similar figure. Okay, so these two rectangles are similar. The larger one, I know that the area already equals 45 centimeters, but I don't know the area in the smaller, so I'm going to put an X there. Okay, that's what I'm trying to find, is that X the area. Okay, remember step 1 is to identify or make the ratio that they give you. Okay, so if I look between the areas, I don't have that one. I got to find it. But if I look between the side lengths that they give me, I have both side lengths. Okay, this is the side ratio. Now it doesn't matter which way you go. You can put the large side over the small side or the small side over the large. But just like in our similar unit, we have to do it the same way every time. So if I put the large one over the small, I have to continue to do that each time. All right, so they give me the side ratio. Okay, I'm going to put the large over the small, and I'll have to do that every time I make a ratio moving forward. All right. I've identified that my variable, the thing I'm trying to find is area, so that means what I'm trying to find is I need to find or convert to the area ratio. All right, so for me to be able to use this side ratio here, I have to make it match the units I have in my areas. So I need to convert the side ratio to an area ratio. Okay, now if we look back on the last slide, to go from a side ratio to an area ratio, I just have to square the fraction. I have to square the top and the bottom. So the math that I'm doing on the next slide here to convert is I'm taking 7 squared and 4 squared, and that equals 49 over 16. Now that I have this converted in an area ratio and I have this area and I want to find this one, now I only have one piece of information missing, I can set up a proportion. Okay, where I use the area ratio that I converted and I'm trying to find X. Now remember I did large over small, so my large area is 45, the actual area, over what I'm trying to find. So remember we do like scale equals real when we do proportions? My scale is the converted ratio and my real is what the actual area is over the actual area. And if you remember, we cross multiply to solve proportions. And I get 14.69 centimeters squared as an estimated area of the small. All right, so if you feel like you've got the hang of this problem, I want you to try the next one on your own. If you don't feel like it, you're not ready for it, you can watch me do another one. Okay, so if you're ready, go ahead and pause the video and then just check to make sure you got it right. If you're not ready, continue watching me do it. All right, so it says use the given areas to find the value of X. Okay, so X well, I guess step one, we're gonna focus on what they gave me. Between the dimensions that they give me, I have both areas. Okay, so they gave me the area ratio. So let's identify that. I'm gonna do small over big. So I'll do 64 over 196. Okay, that's my area ratio. Then step two is identify the ratio that your variable's in. So I need to find x, okay? X is a side length, so that ratio is going to be the sides with 10, okay? If my ratio that I need is, if my x, the thing that I'm finding isn't a side ratio, that means I need to convert the given ratio to a side ratio so that the units are the same when I go set up a proportion. If I set up a proportion and I have dimensions of the units different, it's not going to work. All right, so if you remember from our first slide when we talked about this, to go from an area to a side, I have to square root the top and the bottom of the ratio. So over here, when I convert this, I'm square rooting 64. And I'm square rooting 196. When I do that, I get 8 over 14. Alright, so now that I have the side ratio converted to match my variable, I can set up my proportion now. And remember, we do scale equals real. My scale is the side ratio that we converted, so 8 over 14. And the real dimensions is x over 10, because remember I'm keeping with small to large, so make sure you pay attention that you're doing the same way every time. Alright, so then I cross multiply, so I get 14x equals 80, and I divide 14, and I get x to equal about 5.71 inches, because it's inches squared, so I know it's inches. So, now that we've done this, I want you to continue working on your project. Remember, you need to